A business consultant conducted a study to evaluate the effectiveness of a training exercise that was meant to help improve sales. A random sample of sales personnel was selected to take part in the study. The total monthly sales for each participant was recorded before and after the training. Then they say part of the analysis of the data is shown in the T table below. All right, so as we're answering the question, I'll be explaining what these things mean. So the first question is, explain why an independent samples test was not suitable in this case to test for the effectiveness of the training exercise to improve sales. All right, so first let me illustrate what an independent samples test is. All right, this is a test. Let's say, for example, in the medical field, right, you want to test one medicine against another medicine. Let's say maybe, for example, Panadol versus caffeine. All right, you want to see, okay, how long does it take to cure our patients? So what will happen is you're going to get one group of people, sick people, all right, and you put them on Panadol, and you get another group of sick people, and maybe you put them on caffeine. So what you're going to do is you're going to record on average how long does it take for someone to takes Panadol to get cured. All right. So maybe in your first group, maybe get a group of 20 people and you say, okay, on average, it is 15 days for someone to get well. This is the average time it takes to cure the people on Panadol. Again, you're also going to record for caffeine. On average, it takes, let's say, 18 days for people to get cured. So what this independent samples test does is you're going to take means of different groups, all right? You take the average for each group. If there is no difference between the average, like in this case, difference between the average time it takes Panadol to cure people and the average time it takes caffeine not to cure people. If there's no difference between the means, then it means these medicines, none of them is significant over the other. Okay. Your test will be none of them is significant over the other because their means, the difference of their means is zero. All right. But if you see a situation like this where you see, okay, there's a difference in the means. For Panadol, it takes people 15 days. For Cafimol, it takes 18 days. You're going to notice this difference. And from this difference, you're going to be able to tell, okay, it seems Panadol is better than caffeine. All right. So that's how an independent samples test is. You're going to take two unrelated groups of people. You're going to do a test on both of them, and you're going to get the averages for the both groups of people. If the averages are the same, meaning there's no difference in the means, then there's nothing significant from that test. All right. But if the averages are different, then there should be like in this case, one medicine is superior over the other. But in this case, for this test which is being conducted here, we're not getting two different groups of people. We're using the same group of people. All right. Yeah, we're recording their cells before the training. We're recording the cells before the training, and also we're recording their cells after the training. So an independent samples test wouldn't be suitable because here we're using a related group, meaning we're using the same group of people to conduct the test. We're calculating the average sales before the training and the average sales after the training. So an independent samples test cannot be used because we're not using any unrelated groups of people. We're using the same people to conduct the test. Okay, if you read the notes that I sent yesterday, let's just go through them. An independent samples t-test is used to compare two samples from unrelated groups. Like in that example I gave you, one group you give them Panadol, one group you give them Cafim. Okay. This means that there are different people providing scores for each group. Okay. Now, so the purpose of the test is to determine if the sample means are different from each other. That's the whole purpose of the independent samples test. You get an unrelated groups of people, you get their means, and you want to see if the means are different from each other. But in this case here, since we're using the same people for the same test, so an independent samples test is not suitable. Because we're not using different people, we're using the same people. That's the main thing. We're not using different people to collect the average sales. We're using the same people, so we can't use an independent samples test. And the whole concept behind both of these tests is for the groups that you get, you're going to get the averages. If the averages are not different, then there's nothing significant about the test. But if the averages are different, then there you can say there is something significant. Any questions, colleagues, before we move further? Okay. The next thing is state the 95% confidence interval for the paired differences. So now this confidence interval, this is the region where with a 95% probability, the means of these people who are being studied, the means is going to fall in that range 95% of the times. The difference of the means is going to fall in that region 95% of the time. Okay, so the confidence interval is the interval where 95% of the time the difference between the means of the groups is going to lie. Okay, so in this case here, our confidence interval is this one, negative 16.21020, negative 1.5390. Okay, so the confidence interval, like if we do this test again and we run it again and another time, we might be getting a different difference of means. But even though we get a different difference of means, those 95% of the time they're going to fall in this interval. And also the confidence interval can also be used to tell if there is a significant difference in the means. So for part B, the confidence interval is this one, negative 16.21022, negative 1.5398. This is the region where the difference of the means, because remember, In an independent samples test and a paired samples test, you're getting the difference of the means of the two groups that you are identifying. Okay, it's all about the difference of the means. If there's a difference in the means, like in this case here for this test, right? This test want to say if the training was effective. Okay, so if there's a difference of the means, it means the training was effective. Okay, but if there's no difference of the means, meaning the average sales before the training and the average sales after the training is still the same, then means that uh, the training wasn't effective. All right. Does the confidence interval suggest a significant difference in average sales before and after training? Yes, the confidence interval can suggest a significant difference if and only if it does not contain the number zero. So, what I mean, if we draw a line here, maybe let's say, for example, this is our first confidence interval. This is -3. This is the lower bound. And the upper bound is 7. Such a confidence interval contains a zero. Okay, because as you go from -3 to 7, you have to cross a zero. So if a confidence interval has a zero in it, it cannot suggest a significant difference in the means of the groups. And in this case, it cannot suggest the significant difference in means translates to effectiveness in the program. So in our case here, our confidence interval does not contain zero. Why? Because it's from -16.2 to -1.5. All right. There is no zero in our confidence interval. All right. So once you notice your confidence interval doesn't have a zero, this is one thing that can lead you to suggest that, okay, there should be a significant difference in the means. Yes. Any questions on that? So in this case, our confidence interval does not have the number zero. Give an account of the test that was conducted. So here, the test is to see if the training was effective enough to help these sale people increase their average sales. So what we did, we got a group of people, we measured we got their sales and we averaged it before the training, all right? Then those same people, they went through the training, and after the training, we got their sales and we averaged it. All right, this is what's happening in this test. We want to test if this training course was effective. So the first thing that you do, you get a group of people. Each of them you measure how much sales do they make, how much sales do they make. You get the average, which is the mean. All right, get the average. Then the same people, they go through the training. After the training, you record their sales and you get the average. All right. And if there's a difference in the averages for the sales, it can lead us to suggest that the training was effective. But if there is no difference in the sales before and after training, then we can say there was no difference. So that's the test that's being conducted. A paired samples test. With a paired samples test, you use the same group of people. Independent samples test, you use different groups of people. Okay, that's how you differentiate. One, the same pair of people. The other, it's the same people. Think of it as a before and after test. Okay. State the null hypothesis and the alternative hypothesis. Right? What the null hypothesis is basically what is believed. Okay. What is the status quo? Then the alternative hypothesis challenges the null hypothesis. Right? So with a paired samples test, your null hypothesis, denoted as HO, they are going to say there is no difference between the means. All right. There is no difference between the means. This is mu, which represents the means. You can also write like this: mu minus mu 2, mu 1 minus mu 2 equals 0. The mean or the average of the first group, when you took the test, when the people never took the exercise, when you got the average cells before the training, that's the first mean. And the second mean is coming from after they take the training, the average cells after the people have taken the training. So the null hypothesis is that the difference between the means is 0. So in this case, what this translates to is the training wasn't effective. Think of it like this. You say you get your average score in a test before tuitions. Maybe before tuitions, your average score in a test is 50%. Then after you do tuitions, you write a test and you get another 50%. It means the tuitions are not effective, right? Because you're still on the same level. Okay. So now in this case it's for the training. Okay. So the null hypothesis is suggesting that there is no difference between the mean which was taken before the training and the mean which was taken after the training. There is no difference. Then the alternative hypothesis stating there is actually a difference between the means. And in this case, what it's translating to is the training was effective. So this is the null and alternative hypothesis. So for a paired samples test, independent samples test, these two always be the same like this. The null hypothesis, there is no significant difference, meaning the mean for the first test and the mean for the second test, there's no difference, it's at 0. And the alternative hypothesis said there's actually a difference between the means. And in this case, when we say the difference between the means, we mean the training was effective. Now, when you're dealing with this type of test, especially when you're about to make a decision, your decision will be based on this t value and this one, which is written sig two-tailed. This is called the p value. The p value, it's used as a, what can I say? The rule of thumb is this: if the p value is less than 0.05, okay, if your p value is less than 0.05, right, like in this case, if it's less than 0.05, it means there's a significant difference in the training, right? The p value is just telling you, is just more like evidence against the null hypothesis. The smaller the p-value, the greater the evidence against the null hypothesis. Always remember that. The smaller the p-value, the greater the evidence against the null hypothesis. If you're asking where did the 5% come from, all right, if you have a confidence interval of 95%, you give room for error, okay, because remember, you can never be 100% correct. We are humans, so we tend to make mistakes. So you give room for error. All right. So 100 minus 95, that's 5%. That 5% is also called the significance level. All right. So if the p-value is less than the significance level, which is 0.05, then there is evidence against the null hypothesis, meaning the null hypothesis is not true. Then the second thing, because there are three ways you can do this test. Either you use the p-value rule, where you compare it against the significance level, or you can compare the test statistic against the critical value. For that one, you're going to need the t-tables test. Okay, if the t-test the t-test statistic is greater than the critical value, I put this here on the notes, so I hope you read this yesterday. Yes, these are the three conditions you can use to make your decision for such a test. So if your test statistic, your t-value, right? Do not ignore the negative sign when you're reading the t-value. If it's positive or negative, you take the absolute value of the t-value. Because on the t-table, you won't find any negative numbers. Okay, so you get the absolute value. Let me just show you the t-tables test. The t-table where you can compare. In the exam, you'll be given the t-table, so do not worry. T-test table. Let it just load. So yeah, you compare the test statistic to the critical value, which you find on the t-table. So I don't know why this was not open. Okay, as we're waiting for it to open, once it opens, I'll show you. Yes. Or you can also check the confidence interval, right? So these are the three guidelines you can use. So like for this test, before we can make a decision, we'll go through also these three guidelines to make sure that there is a significant difference between the means, which translates to that the training exercise was effective. All right. So, okay, here it is. All right. So this test, first you have to look for the significance level, and the type of test. So this test, they've told us it's a two-tailed test. Okay, two-tailed test. And our significance level is 5%, which is 0.05. So you come here, two tails on this part, two tails, significance level 0.05. Then you go to the degree of freedom. In this case, degree of freedom is 7. Just wait for it to load. Huh? Was that the question? Okay, as we wait for it to load. No, it's taking long to load. Okay, so the test statistic here you say negative 2.866, negative 2.861. That's the test statistic. It's what is used to measure against the critical value. The p-value, here it is, where it's written sig two-tailed. This is where you find the p-value. Value is 0.024. So test statistic negative 2.861, p-value 0.024. So number 4, the decision arrived at and your conclusion. Uh-huh. Oh yes, oh yes. Do not worry, madam, you are covered, okay? If you want a catch-up class, we'll do even a catch-up class. Okay. Me, I want to make sure that until you understand, yes, yes, until you understand, yeah. So before we make our decision, let's go through the. Okay, okay. Yes. So before we make our decision, let's go through the three conditions. Number one, we saw confidence level does not include a zero. So it's suggesting there's evidence that this training, this, what do you call this? This training was effective. Number two, let's see the test statistic. Now remember, when you're going on the t-tape, ignore the negative sign because you're only going to find positive signs here. Okay. So you ignore the negative sign, you're going to take the absolute value, meaning absolute value is just the number without considering any positive or negative sign. Okay, so I don't know why here it's not coming up here. Okay, let's check if also as we're waiting for that table. Is 0.024 less than 0.05? Yes, it is. So our P value is less than 0.05, suggesting strong evidence against the null hypothesis. Okay, so now what's left is just the T table. Yes, you come here, two tails, 0.05, degrees of freedom, 7. Okay, degrees of freedom, 7. Two tails, significance level, 0.05. So where they intersect, I don't know where to zoom on this, but I'll send you a copy of this table. Okay, here I'm failing to zoom on it. But where they intersect, the degree of freedom for 7, where it intersects with the significance level of 0.05, we get a value of 2.365. Okay, this is our critical value, 2.365. All right, so we get also the absolute value for our test, 2.861. It is greater than the critical value. So our decision in this test is we reject the null hypothesis. Because when you're rejecting these tests, you don't just say the null hypothesis is not true. It's either you reject the null hypothesis or you fail to reject the null hypothesis. So here we reject the null hypothesis, which states that the difference in the means is zero, meaning there's no effectiveness in this training. We've rejected that null hypothesis. And that implies that there is a significant difference, meaning the training was effective. Okay. Our confidence level didn't have a zero. Our p-value is less than 0.05. And our test statistic, absolute value of the test statistic, 2.861, is greater than our critical value of 2.365. So we have enough evidence to reject the null hypothesis and accept that this training was indeed effective.